Touchscreen is an electronic display screen. A user interacts with the display by fingertip movements. The touchscreen are also pressure sensitive and can be used by tapping fingers or a stylus. There are basically two types of touchscreen technologies, the resistive touch and the capacitive touch. The resistive touchscreen are more often found at ATM centers and supermarkets. Resistive touchscreen can handle only single touch, however, are more durable and consistent. Before the era of touchscreen technology, people with push-button telephones had to waste a lot of time to write simple sentences. Usually it took 1 to 2 minutes. It's clear that the touchscreen makes our life better and easier by saving our time on basic telephonic stuff.
In 2010, South Korea experienced a particularly cold winter. People couldn't activate their smartphones while wearing gloves, so they began wielding snack sausages, causing one company to see a 40% rise in sausage sales. So what could sausages do that gloves couldn't? In other words, how do touchscreens actually work? In 1965, the first touchscreen was invented to help British air traffic controllers efficiently update flight plans. However, the technology was too unwieldy and expensive for widespread use. Over the following decades, engineers further developed this technology and experimented with alternative kinds of touchscreens. Soon, resistive touchscreens dominated the market, but then, in 2007, Apple released the first iPhone. It was a breakthrough, yet it functioned using the same principle. Voltage that machine software reacts to. Resistive touchscreens can be a little unresponsive, but they're generally cheap and durable, so they're favored for industrial or main use. A vast majority of touchscreens produced in 2007 were resistive, but in years following the iPhone release, most became capacitive. Individual models vary, but smartphone touchscreens today typically consist of a protective insulating glass exterior, and the LCD screen are several sheets. One is lined with rows of a transparent conductive material that carry an alternating electric current. A thin insulating layer separates these conductive lines from others that are arranged as columns, one on top of the other lines from a grid. The points where they intersect are called nodes. The iPhone's battery draws electrons along the first layer of lines, and some electrons accumulate at every node, creating a small electric field. These screens are called capacitive touchscreens because the nodes act like capacitors by storing charge. They are generally easier to use than resistive touchscreens because they interact directly with your finger without the application of force. Your body is a great conductor and is constantly transmitting electric currents. Why? Because about 60% of your body is water. Now, while chemically pure water is an insulator, most water is impure. The water inside you is loaded with ions, atoms or molecules that have a net electrical charge, so when you click on the app, your finger functions like a third electrical line. It interacts with the existing electrical field, which induces a weak electrical current that travels through your finger and eventually back into the phone. This changes the amount of charge at the affected nodes, and voltage measurements along the second layer of lines tell the phone's microprocessor which part of the screen is being touched. However, if you try using a smartphone while your hands are wet or gloved, you will probably have some trouble. Both interrupt the electrical connection between your finger and phone. If water is splashed across the screen, it might trigger many underlying nodes. If water is splashed across the screen, it might trigger many underlying nodes. And the phone could act like you have touched it in multiple places at once. On the other hand, gloves are insulators, so the charge has nowhere to go. Meanwhile, objects that conduct electricity about as well as your finger, like banana peels and certain processed meats, can all activate the screen. Knowledge that can come in clutch when you are in a pickle.